Hello friends, today we will study series RC circuit, single phase series RC circuit. This is the circuit in which we are connecting resistance and capacitance in series with a single phase AC supply. So friends, your circuit will look like this. Here what we are having a resistor and capacitor, and here we are connecting single phase AC supply. So when this voltage is applied to this circuit, your voltage will get divided in between two parts. Some voltage will drop across resistance, some voltage will appear across capacitance. So we are calling them as VR and VC respectively, resistor voltage and capacitor voltage, or voltage across resistor and voltage across capacitance. So when we are connecting AC supply, current starts to flow through this circuit. When this current passes through this resistor and capacitor, voltage will develop across both of them. Now let us look at some terminologies. Suppose capital V is the RMS value of our applied AC voltage. Suppose I is the current flowing through the circuit, RMS value of the AC current. And when this current passes through this resistor, voltage will drop across resistor, and that value will be I into R according to Ohm's law. Similarly, voltage across capacitor will be I into XC. XC stands for reactance of capacitor. So we already know that in pure resistance, in the last lecture we have seen behavior of pure resistance and pure capacitance. So we know that in pure resistance, voltage and current are in phase, means phase difference between them is 0 degree. Whereas in pure capacitance, voltage and current are 90 degree out of phase. In case of pure capacitance, current leads voltage by 90 degree. You can predict this from phasor diagram also. So friends, here you can see that voltage and current, this is the phasor diagram for pure resistance. In pure resistance, phase difference is 0, hence we can say that voltage and current through the resistance are overlapping each other. Whereas in case of pure capacitance, your current is leading by 90 degree with respect to voltage, hence there is phase difference of 90 degree and current is leading. Okay. Now if we superimpose these two phasor diagrams on each other, we will get the phasor diagram like this. So on x-axis always you have to take current, the quantity which is common to resistor as well as capacitor. We know that in this circuit this current is common to resistance as well as capacitance because they are connected in series. So what we are doing, we are taking current on x-axis. So this is your current I, we have taken the current on x-axis. Now we know that for pure resistance, voltage and current are in phase. So VR and I are overlapping on each other because phase difference between them is 0. But if we look at the capacitor, we know that if this is the value of current, if this is the phasor diagram of current, your voltage will be lagging by 90 degrees. Phase difference for voltage for capacitance is 90 degree and current is leading. So what you have to do, you have to take horizontal projection from this point, you have to take vertical projection from this point, and whatever cross section point you are getting, you have to join these 2 points. You have to join these 2 points, and whatever you are getting, that will be the final value of your applied voltage, applied RMS AC voltage. Already you have drawn the phasor diagram for current, and now you are getting the phasor diagram for total voltage. So the phase difference between total voltage and total current is called as phi. It is indicated by Latin letter phi. Friends, here you can see for pure resistance phase difference is 0, but for pure capacitance phase difference is 90 degree. Now we are taking combination of resistance and capacitance. So your phase difference will be neither 0 degree nor 90 degree. It will be in between 0 and somewhere in between 0 and 90 degree. So your phase difference will not be as low as 0 degree. It will not be as high as 90 degree. It will be somewhere in between 0 and 90. So you are getting this inclined line or inclined phasor diagram for this final voltage. So you are getting the phasor diagram like this. So if you compare total current and total voltage, you will get the phasor diagram with phase angle of 5 degrees, and this phi will be in between 0 and 90 degree. Okay. Now this voltage, total voltage is resultant of voltage across resistance and voltage across capacitance. So but here you can find that VR is on x-axis whereas VC is on y-axis. So if you have to find the value of V, you have to take phasor addition, or we can say that vector addition. So what is basically vector addition? If you are taking vector addition, your V, final voltage V, is combination of VR and VC, but you have to take bar on their head. So this bar indicates that this is not a simple algebraic addition, this is a phasor addition or phasor sum, or sometimes it is also called as vector sum. So if you want to remove this bar, you have to take square on both sides. So your equation will be like this: V square is equal to VR square plus VC square. If you want to remove square of V, you have to take square root on right hand side. So you will get V is equal to in root VR square plus VC square. Friends, already we have derived the value of VR and VC. So what is your VR? I into R, and what is your VC? I into XC. So same values we are substituting over here. So IR square plus IXC bracket square. So friends, here I is common in both terms. So what we are doing, we are taking I common. So when this I square comes out of this root, we are getting I. So V is equal to I square root of R square plus X square. Okay. And if you want to find the current, so your current will be voltage upon in root R square plus X square. So this parameter R square plus X square is called as impedance. So what you are getting, V by Z. So your total current is total voltage upon total impedance, and this is measured in, this impedance is measured in ohm, whereas current will be measured in amperes. So here Xc stands for capacitive reactance. It is the opposition to the flow of current by the capacitance. Okay. Friends, again here we are getting Z is equal to in root R square plus X square. So you can say that your impedance is combination of resistance and reactance. It is actually phasor addition of resistance and reactance. So it is phasor sum of resistance and reactance of the circuit. So if your circuit contains resistance and reactance, if we combine them, if we take their phasor addition, what you are getting? You are getting impedance. Okay. And impedance is always measured in ohm, because impedance is due to the combination of resistance and reactance, and resistance as well as reactance are measured in ohm. So your impedance should be measured in ohm only. Okay. And it is the total opposition to the flow of current by resistor as well as inductor as well as capacitance. Okay. So friends, now we are studying various parameters of this RC circuit one by one. So friends, now our first parameter is phase angle, or it is also called as phase difference, and it is indicated by Latin letter phi. So for calculating phase difference, first of all you have to draw the waveform of voltage and current, because phase difference is indicated in between phasor diagram of voltage and current. So from phasor diagram we can also draw the waveform of voltage and current. So we already know that in pure resistance, voltage and current are in phase, means their phase difference is 0. Whereas for pure capacitance, current is leading with respect to voltage by 90 degrees. So your phase angle is 90 degree. But in this case, our circuit is neither purely resistive, neither purely capacitive. So our circuit is combination of R and C. So our circuit contains some resistance as well as some capacitance. So your phase angle will be in between 0 and 90 degree. Okay. Now what is the standard equation for voltage? V is equal to Vm sine of omega t. Okay. But in this RC circuit, current is leading. Okay. So you have to indicate that phase difference also. So your equation of current will change. Now what is your equation of current? I is equal to Im sine of omega t plus phi. So this plus indicates that current is leading with respect to voltage, and by how many degrees? So it will be indicated by the value of phi. So value of phi will be in between 0 and 90 degree. So this phi can be anything in between 0 and 90 degree. Now these are the equations, mathematical equations for voltage and current. Now if you want to draw the phasor diagram, waveform, how you can draw this? You can draw the waveform by using these equations. So friends, here we are having V is equal to Vm sine of omega t, and there is nothing with omega t. So nothing means here we can add 0 degrees. It means what? Your voltage will start from 0 degrees. So your voltage waveform will start from 0 degrees like this. So you will get the sinusoidal waveform for voltage like this. And from this equation of current, now you can see that current is leading with respect to voltage by how many degrees? 5 degrees. Okay, so value of phi is in between 0 to 90 degree. So what we are doing, this dotted line indicates the waveform for current, and current is leading with respect to voltage by 90 degrees, angle phi, and the value of phi will be anything in between 0 and 90 degree. So what happens when we draw the waveform? We will see that voltage is starting from 0 degree, but current is starting 5 degrees earlier. So this we can call it as current is leading with respect to voltage. Okay friends, value of this phase angle is given by this formula. So phi is tan inverse of minus Vc upon Vr, voltage across capacitance upon voltage across resistance. So Vc is I into Xc and Vr is I into R. So when we cancel I, what we are getting, our formula will be like this. Your phase difference is tan inverse of minus Xc upon R. This minus sign indicates that voltage is lagging and current is leading. Okay, so your phase difference will depend upon two factors. One is Xc and another is R. Xc again depends upon frequency and value of capacitance. Okay, so if we change frequency or value of capacitance or value of resistance in this circuit, the value of phase difference will go on changing. Okay, so if we use high value of Xc, your phase difference will be higher. Phase difference is directly proportional to the value of capacitive reactance. If we go on increasing the capacitive reactance, your phase difference will go on increasing, but it will never go beyond 90 degree, or it will never reduce below 0 degree. It will be always in between 0 and 90 degree. This you have to remember. So friends, our next parameter is impedance. We know that what is impedance? Impedance is the current opposition to the flow of current by the R and C components. Okay, so resistance offered by the circuit to the flow of current, and we have already seen that what is the value of Z. It is the phasor sum of resistance and reactance. So if we combine resistance and reactance, we are getting impedance. Resistance and reactance both are measured in ohm, so impedance is also measured in ohm. So what is your reactance? So Xc is, actually it should be 1 upon 2 pi Fc. Okay, so Xc is 1 upon 2 pi F into C. So this is nothing but your impedance. Okay, now our next parameter is power consumed in the circuit. Now power can be of two types. One is instantaneous power and another is average power. Instantaneous power is indicated by small p, small letter p. If p is small, it means it is an instantaneous power. So it is multiplication of voltage and current. So we already know the equation of voltage and current. So voltage is Vm sine of omega t, current is leading, so Im sine of omega t plus phi indicates that current is leading. Now if we use trigonometric rules, what we are getting, sine A into B is what? 1/2 cos A minus B cos A plus B. Okay, so if we use this, what we are getting, small p is equal to Vm Im, then 1/2 cos A minus B. So what is A? Omega t. And what is B? Omega t plus phi. So what we are getting? Minus phi. And if we add them, what we are getting? Minus cos 2 omega t plus phi. Now cos of minus phi is what? Cos phi. So what you are getting? Vm Im by 2 multiplied by cos phi. We are solving this bracket. So what we are getting? Vm Im by 2 multiplied by cos phi minus Vm Im by 2 cos of 2 omega t plus phi. Okay, so if you carefully look at these parameters, what you are observing, this Vm Im by 2 and cos phi, all these are parameters are constant. Okay, so this is called as fixed power. This fixed power will never change. Okay, and in this parameter you are getting omega t. Omega is changing, omega t, time is changing. Okay, so this part is variable part. So what happens, this part does not contains omega t, so this part is fixed part and this part contains omega t, time is changing, so this is variable part. Okay, so your instantaneous power consists of two parts, fixed part as well as variable part. Now next is average power. It is indicated by capital letter P and it is always measured over one cycle. Okay, so what you have to do, you have to take integration of the previous equation with respect to omega t. So if you take integration of previous equation, what you are getting in that equation, we are having fixed part as well as variable part. This is the equation I am talking about. If we take integration of this fixed part as well as variable part, now this is what? Instantaneous power. If we take integration of instantaneous power, we are getting average power. So if we take integration of this and if we take integration of this, we will get average power. Now if we integrate this second term, the integration will be 0 because integration of variable part is always 0. Okay, so we are considering only fixed part for calculating average power. So after integrating previous equation, we are getting average power. So it comes out to be Vm Im by 2 multiplied by cos phi. If we bifurcate this 2 into root 2 multiplied by root 2, so we are again getting 2. So Vm by root 2, Im by root 2 multiplied by cos phi. So Vm by root 2 is capital V, Im by root 2 is capital I, and this is cos phi. So what is your average power? It is total voltage or RMS voltage multiplied by RMS current multiplied by cos phi. Cos phi is your power factor. You can also calculate the power by another way. So what is your total power? Power across resistance plus power across capacitance, because your circuit contains resistance as well as capacitance. So what is power? Vi cos phi. So in resistance we are getting VR into I into cos phi. In capacitance we are getting Vc into I into cos phi. Now we know that for pure resistance phase angle is 0 degree, for pure capacitance phase angle is 90 degree. So what is cos 0? 1, and what is cos 90? 0. So Vi into 1 plus Vi into 0. So second part becomes 0. So what you are getting? VR into I. Now what is VR? VR is I into R, current multiplied by resistance. Okay, multiplied by this current. And what is current? Voltage upon impedance, V by Z. So I into R multiplied by V by Z. Okay, so if we take voltage and current outside, so we will get V into I multiplied by R by Z. And we know that R by Z, the ratio of resistance and impedance, is called as power factor. So what you are getting? V into I into cos phi. So R by Z is nothing but what? Power factor. Okay, so what you are getting? P is equal to V into I into cos phi. This is nothing but your average power over one cycle. Now friends, next parameter is power curve. It is nothing but the waveform of power. How power is changing with respect to voltage and current when they are changing with respect to time. So we have already drawn a waveform for voltage and current. We know that in RC circuit your voltage is starting from 0 degrees like this, so you are getting sine waveform like this. And for RC circuit current is leading, so current is starting earlier with respect to the voltage. Okay, so this blue pink color indicates your current, black color indicates your voltage. Okay, now if I want to draw the power curve, so we know that what is power? V multiplied by I. So you have to basically multiply voltage and current. So from this area, this to this area, you can see that pink color means current is positive but voltage is negative. So positive multiplied by negative. Okay, so you will get negative power curve. Okay, so you will get negative power curve like this. Okay, from this area to this area, voltage and current both are positive, so your power curve is also positive like this. Okay, from this area to this area, voltage is positive but current is negative, so your power curve is also negative. From this area, this time to this time, voltage and current both are negative, so negative multiplied by negative, so you are getting power as positive. Your power will be positive. So in this way you will get the power curve for RC circuit. Okay, and now we can see that sometimes power is negative, sometimes your power is getting negative, and sometimes power is getting positive. So what does this mean? If power is positive, it means power is flowing from source to the load. Okay, and if power is negative, it means what? Power is flowing from load to the source. So positive power means what? Power is getting consumed in the circuit, and negative power means what? Power stored in the capacitor is returned back to the source. So power will flow from load means capacitor towards source when power is negative. Okay. Now our next parameter is impedance triangle. So it is a triangle which indicates all the values which are measured in ohm, means resistance, reactance as well as impedance. Okay, so for this we can draw this impedance triangle by using phasor diagram. So we already know how we have drawn the phasor diagram. So this is your voltage across resistor, this is your voltage across capacitor, and in between them we are getting RMS value of applied voltage or total voltage. Okay, now what I am doing, I am shifting this VC from this point to this point. So how your phasor diagram will look like? VR I am keeping as it is, V I am keeping as it is, and VC I am drawing here. So I am getting a triangular shape. Now what is your VR? I into R. What is your VC? I into XC. And what is your V? I into Z. Now if I remove current from all these three terms, what I am getting? I am getting R on x-axis, XC on y-axis, and Z on this diagonal axis, okay, or hypotenuse. So I am getting a triangle like this. It is having R on one side, XC on another side, and Z on the third side. Okay, and all these parameters are measured in ohm. And resistance, and if we combine XC and resistance, means reactance and resistance, if we combine, we are getting impedance. So this triangle will help you to calculate impedance. Hence this triangle is also known as impedance triangle. Okay, and friends,